Okay, geometry students, in this video we will be studying Pythagorean Theorem and the distance formula. Okay, Pythagorean Theorem, by the way, is a theorem or a formula that's used on right triangles. Okay, and the distance formula is used to find the distance between 2 points. Okay, so those are the two things we're going to look at today. Your heading is, well, your first heading, actually, let me go ahead and change this right now. Let's go ahead and make your heading a Pythagorean Theorem and distance formula. Okay, so go ahead and fix that, please, if you would. Your heading today is the Pythagorean Theorem and distance formula, lesson 4.4, and go ahead and include today's date, if you would, please. Okay, go ahead and include today's date. All right, the Pythagorean Theorem and distance formula, lesson 4.4, and be sure and include today's date. Please go ahead and copy all this down. Now, students, listen, everyone should be taking notes. Everyone should have their notebooks out, and we should be writing stuff down, okay? So make sure you're taking notes, please. All right, let's continue on. Now, we are going to start first with Pythagorean's theorem. Before we do that, we need to quickly review the names of the three sides of a right triangle. So please take some really good notes on this, okay, guys? First of all, we know by now that a right triangle is a triangle that has a right angle, okay? So go ahead and copy this in your notes if you would, please. And go ahead and put a right angle here. Now, the right angle always points. See the right angle right here? It's kind of like an arrow. The right angle always points to the hypotenuse, okay? So this side right here is called the hypotenuse. Please write that in your notes. Okay, this side here is called the hypotenuse. Now the other two sides that make up the right angle, this side here and this side here, make up the right angle. The two sides that are not the hypotenuse are called legs. So a right triangle always has two legs, okay? So make sure you copy all this down, and we're going to move on in just a second. We need to know this. Before we can use Pythagorean's theorem, we need to know what the legs are and what the hypotenuse is, okay? The hypotenuse is always the side directly across from the right angle, and the other two sides are the legs, okay? Now that we've covered that, let me explain what Pythagorean's theorem does for us. It is a formula that allows us to find the length of a side of a right triangle. Emphasis on right triangle. It has to be a right triangle when we know the lengths of the other two sides. In other words, if I give you a right triangle and you know the length of how many sides, 2, you can then very easily find the third side by using Pythagorean's theorem. Okay? Now, here is Pythagorean's theorem. Of course, L stands for your leg, L stands for your other leg, and H stands for your hypotenuse. Okay, so you have leg squared plus leg squared equals hypotenuse squared. Okay, take a second and write that down, please. This is Pythagorean's theorem. L squared plus L squared equals H squared. Leg squared plus leg squared equals H squared. Now in the past, you've probably seen it written like this. And I have no problem with that. And the reason they use A, B's, and C's is because in geometry, when you prove Pythagorean's theorem, you label some of the sides A, B, and C. Okay? But I would much rather use this formula here so that you know which unknowns are your legs and which unknown is your hypotenuse. Okay? So there's the formula of Pythagorean's theorem. All right, let's go ahead and continue on. Now let's jump right into this and let's use Pythagorean's theorem on two right triangles. Remember, you can only use Pythagorean's theorem on right triangles. Please don't forget that, students. It's very important. You cannot use Pythagorean's theorem on an oblique triangle. It must be a right triangle. And then after we do 2, I'm going to give you 2 to do on your own, okay? So here we go. Let's go ahead and get started. Let's solve this right triangle. So go ahead and copy this in your notes. We're going to solve for x, okay? Now notice right away we have a right triangle. Also notice that we know two sides. We're only missing one side. So as soon as you see your right triangle, students, and as soon as you see that you know two sides, think right away Pythagorean Theorem. So go ahead and write this in your notes, okay? Now, I know a leg, so let's put that leg here. I know another leg, so let's put that leg here. And my hypotenuse is x, so we'll put x here. There we go. Now, 2 times 2 is 4. 3 times 3 is 9. Please don't put 6 here, guys. Remember, 3 squared is not 3 times 2. 3 squared is 3 times 3, so 9 equals x squared. Okay? Now, let's add these two together. 13 equals x squared. Now, I'm not sure here, the supervising teacher might have to help you guys a little bit to show you where your square root button is on your calculator. However, and if you don't have a calculator, at the very first day of class, when I listed things out that you all need to bring to class every day, one of those things was a calculator, okay? And so you do need your calculators every day. Now, if you don't have one today, you can share with someone if you need to, but you need to have one every day. So here we go, and especially during quizzes, I don't want you guys sharing calculators during tests or quizzes, okay? So make sure you bring one every day. But anyways, here's what we're going to do. Notice that we have x squared over here, okay? And I want to get x by itself. So what I'm going to do is I'm going to take the square root of x squared. However, you cannot take the square root of one side unless you take the square root of the other side, okay? So I take the square root of both sides. Now the reason I did that is so that this x squared here becomes an x. The square root of x squared is x. Now, the square root of 13 is going to be a decimal, so I'm going to go ahead and type that into my calculator. Square root of 13, enter, and you should get this, 3.60555125. I'm just going to go ahead and put 3.6, okay? So there's your answer. Okay, so the length of this side right up here is 3.6. Pretty simple, guys. Really, you should be able to solve these pretty easily on a quiz or a test, okay? Let's try another one, all right? Remember, if I'm going too fast, let the supervising teacher know, Mr. Hamill or whoever it is, and just pause the video, okay? Let's go ahead and try another one. You can work ahead, or you can watch me, okay? Copy this in your notes, please, and we're going to solve for x. Okay, copy this in your notes. We're going to solve for x. Okay, here we go. We notice right away that we have a right triangle. Secondly, we know two sides, and we're looking for the third side. So right away we should think Pythagorean Theorem. Okay. Now one of my legs is 8, so I'll put an 8 here. The other leg is x, so I'll put an x here. And then of course my hypotenuse is 11, so I'll put an 11 here. Now let's go ahead and simplify. 8 times 8 is 64, plus x squared equals 121, 11 times 11. Now your goal is to get x squared all by itself. In the last problem over here, x squared was already all by itself over here completely right away, okay? So all that we had to do was take the square root of both sides. But here, we're going to have to take the 64 over and make it a negative 64, okay? There we go. So now we're left with x squared equals, let's see, 57, I believe. Okay? And now that x squared is all by itself, now we can take the square root of both sides. And of course, the reason we did that is because the square root of x squared is x. And the square root of 57 would be, let me grab my calculator here real quick. Square root of 57 is 7.5498344335. I'm just going to put 7.5. Okay? There we go. So we found the length of this leg right here, 7.5. Okay? So guys, I hope you're understanding this and grasping this, okay? You need to be able to do these pretty quickly, okay? And of course, accurately. So I want you to go ahead now at this time and pause the video. And Mr. Hamill, or whoever the teacher is, if students are not doing these two problems, just email me their names and I'll take care of that with their grades, a class grade or whatever. But everyone should be working on these two problems, okay? So go ahead and pause the video. Let's work on this problem and then this problem here. And when everyone's finished, go ahead and turn the video back on and we'll see how you guys did. Okay guys, hopefully everyone is finished. Here we go. Let's take a look at this first problem here. Now we notice here that we have a right triangle and that we have that we know two sides. And we're looking for the third side here. So we should be thinking right away Pythagorean Theorem. Okay? So L squared plus L squared equals 8 squared. Well, one leg is 3. The other leg is 4. And my hypotenuse is x. Okay? So there we go. Well, 3 times 3 is 9. 4 times 4 is 16. Now, add these two together, I would have 25 equals x squared. And now, take the square root of both sides, square root of 25, and the square root of x squared. Well, the square root of x squared, of course, is just x, and the square root of 25 is 5. So there we go. We got it. X equals 5. So my answer would be 5. Okay? Hopefully you did well in that. If you made any mistakes on this problem in your notes, I would encourage you to cross off or erase your mistakes and fix those so your notes are accurate, okay? Alright, let's take a look at this problem over here now. We should notice right away that we have a right triangle and that we know two sides. We're missing a third side. So right away we think Pythagorean Theorem, okay? There we go. Now one leg is 5. The other leg is x. And my hypotenuse is 8. Okay? There we go. Now 5 times 5 is 25. Of course, x squared is just x squared. And 8 times 8 is 64. Now we want to get x squared all by itself. So bring the 25 over and make it a negative 25. And when we do that, we're left with x squared equals, let's see, 39. Okay? Now we take the square root of both sides. The square root of x squared is x, and the square root of 39. Let me grab my calculator real quick here. Square root of 39 is 6.244997998. So I'm going to put 6.2. Alright, and there we go. And that's not good. There we go. Okay? So I hope this is making sense. Students, you should be able to, when you're done with your homework tonight, be able to solve a right triangle and find the length of a missing side by using Pythagorean's theorem, okay? All right, let's continue on. Let's move on now to the distance formula, okay? The distance formula allows us to find, there should be a D right there, allows us to find the distance between 2 points, okay? That's what the distance formula does for us. Here's the distance formula. Go ahead and copy this in your notes if you would, please. The square root of x minus x, quantity squared, plus y minus y, quantity squared. And I'll pause here just a second while you guys copy that down, okay? Go ahead and copy down the distance formula. The square root of x minus x, quantity squared, plus y minus y, quantity squared. Okay? Okay, now let me show you something, students, real quick. You do not need to write this down, just watch, okay? Whenever you're given two ordered pairs, like we are here, and I ask you to find the distance between these 2 points, or the distance of this line right here, whenever I ask you to find the distance between 2 points, Now that's the same thing, students, as looking for or finding the distance of a line, okay? So when I ask you to find the distance between 2 points, I'm basically asking you to find a distance of a line. Now understand, if I gave you a line like this, a horizontal line, that would be easy. You would just count the spaces. The distance would be, you would start here and you would go 1, 2, 3. So the distance would be 3. And if I gave you a vertical line, it would be very easy to find the distance, would it not? You would start here and just count the spaces. 1, 2, 3, 4, 5. So the length of this line would be 5. But where it becomes difficult to find the length of a line is when you're dealing with a slanted line, a diagonal line. Okay, so that's what the distance formula is for. Now, what I want to show you is you do not have to graph the line to find the distance, okay? So we're going to go ahead and find the distance between these 2 points without even using a coordinate plane. So go ahead and copy that in your notes right here, please. Go ahead and copy that in your notes. -2, 2, and 6, 5. Okay? Go ahead and copy that in your notes, please. And I want us to find the length of this line, or the distance between those 2 points. So please take some really good notes. Here we go. First of all, here's your distance formula. So write this down, please. X minus x quantity squared plus y minus y quantity squared. Now, this is your x, this is your y, this is your x, this is your y, okay? Let's be really careful with our signs here. And by the way, students, if you struggle with sign numbers, positive and negative numbers, just use your calculator, okay? Nothing wrong with that at all. So feel free to do that, okay? So here we go. We have -2, that's my first x, and minus, so minus 6. Okay? Plus, parentheses, then a y, so here's my y over here, 2, then minus, and then 5. Quantity squared, okay? Now again, students, if you struggle with sign numbers, positive or negative numbers, just use your calculator, okay? For example, -2 minus 6. Well, you should know that's -8. But if you don't, then use a calculator. Plus 2 minus 5, that's -3. Now, when you square a positive number, -8 times -8 would be 64, and 3 times 3 would be 9. Okay? And when you square a negative, it comes out positive. -8 times -8 is 64, and -3 times -3 is 9. Now when you add those two together, you get the square root of 73. Now if I asked you to leave your answer in radical form, then you would leave your answer like this. Okay, students, but if I asked you for decimal form, then you would go ahead and type this into your calculator, which we're doing now, and you would get this up right here. 8.544003745. So I'm going to put 8.5. There you go. So the distance of this line here is 8.5 units. Okay, there we go. 8.5 units. Okay? Let's try one more of these students, then we'll be done with the video, okay? Just one more. Now, once again, students, you do not need to write the coordinate plane. You don't need to draw this if you don't want to, okay? But there's the line that we're going to find the distance of, okay? We're going to find the distance or length of this line. Or you could say we're going to find the distance between 2 points, okay? And you do not need to graph this on a coordinate plane. So go ahead and copy this in your notes like this, okay? So we're going to find the distance between -5, 4, and -1, negative 3. Okay, so here we go. Take some really good notes. You can work ahead if you want to. It's up to you. Here's your x, here's your y, here's your x, here's your y, okay? And here we go. And by the way, if you're wondering, students, it does not matter which x you put in first, and it does not matter which y you put in first, okay? In this formula here, it doesn't matter because you're going to square the result anyways, so it does not matter. All right, here we go. Our first x is negative 5, negative 5. Then look at your formula. You put a negative sign, and then your next x is negative 1. So you've got a double negative here, so be careful, okay? You have negative 5 minus negative 1 plus, and here's your y. Your y is a 4. And the next in your formula is a minus sign, so minus, and then y, which is negative 3. Quantity squared, okay? Now, again, if you're not very strong with your positive and negative numbers, then use a calculator if you need to. But negative 5 minus negative 1 is really negative 5 plus 1. So you would get out negative 4 squared plus 4 minus a negative 3 is the same thing as 4 plus 3, so you would have 7 squared, okay? If you square negative 4, you get 16. If you square 7, you get 49, okay? Add those two together, and you will get the square root of 65. Now, if I asked you to write your answer in radical form, you would leave your answer like this, okay? But if I asked you to write your answer in decimal or whole number form, then you would type this in your calculator. Square root of 65, hit enter, and you will get, in this case here, 8.0622577748. So 8.06 would be fine, okay? And I really don't get too hung up or worried about where you round, as long as you round accurately, okay? Wherever you choose to round, make sure that you round the correct way, okay? But that's it for the video. I hope this has made sense. Let's very quickly review. You need to know what Pythagorean Theorem is, and you need to know that it only works on right triangles, and it helps you find a third missing side, okay? So make sure you know how to solve problems like this, or these, okay? Then you need to know the distance formula right here, and you need to know the distance formula helps you find the find the distance between 2 points, okay? You need to know that. So you should be able to solve problems like this and like this, okay? All right, if you have any questions, don't hesitate to call or email.